What if I told you that two dictionaries can be equal but not equal at the same time? Let me show you. So we'll go ahead and have two dictionaries here. We'll just go ahead and print them out and do the equal comparison. Go ahead and save this. And as you see, this gives us a true result. So even though we switched the order on the second one, Python says these dictionaries are the same. But with an ordered dictionary, order actually matters, and that can be a big deal. So we'll go ahead and convert this to an ordered dictionary. We'll just import collections from ordered dictionary. Go ahead and print this. And this gives us a false result. So what's going on here? If you're curious as I am, you'll definitely want to stick around and watch the entire video so you don't miss out on why this happens. Plus, I'll show you the benefits, more benefits of using an ordered dictionary over a regular dictionary. Magandang araw. Ako si Kuya Code. Welcome back to my channel where I teach Python through coding challenges and HackerRank. Today we'll be looking at some differences between ordered dictionaries, comparing them to regular dictionaries. So before Python 7.3, whenever you would print out the dictionary itself, it would give you the elements in random order. So just as an example, I don't actually have Python 3.7, so I'm just going to simulate it using random. So let's say we have this older Python dictionary here. We can just, again, this is a simulation, import random, take the keys, list p dot, or it's actually it's order pi dot keys, and then we can random dot shuffle keys, not snuggle, or suggle, shuffle keys, and then just print. So if you print that, let me just do it like that. If you print that, you can see that the order is different. We actually have 1, 2, 3, or 1, 2, 3, and this printed out 3, 2, 1. And if I do it again, now it prints out 3, 2, 1 again. Let's see here. Now it prints out 1, 2, 3. So it's this case it happened to be the same, but it's not guaranteed. So again, just to be clear, in older Python, if you were to print it like this, it would treat it as if it was printed like that. But obviously in newer Python, you can just print it regularly, and the order is going to be always the same. It's always going to print out 1, 2, 3, which obviously is good. But the thing is, though, if dictionaries already remember the order, why do we still need ordered dictionaries? It turns out that ordered dictionaries are still useful if you care more specifically about the order, like comparing items, and there are extra features that I'm going to show here. So first, let's demonstrate the differences when you're comparing two of them. So for example, if we take the regular dictionary here, I will just uncomment this. We could treat it as if, imagine you're converting into a set. So even though these two are in reverse order, this one has 2, 3, this one has 3, 2, even though these are in different orders, when you convert it to a set, it always prints them both in the exact same order. Then if you do the comparison, it would show that they're exactly the same. So that's the way I like to imagine the comparison with two regular dictionaries: 1 and 1, 2 and 3, and 3 and 2. So that's what happens when you zip it up. But now that these are zipped up, what you can do is just print, check if all is true. We're going to put in our equation here, which is basically just that k1 is equal to k2. And then for k1, k2 in zip, p2, q2, we're going to just, it's basically just going to give us a true or false if all of these are true or all of these are false. So I forgot to close it. So if we do it this way, and I'll just turn this off, this is going to give us false, because what it's doing, we have in zip p2, q2, which is this whole thing. We're taking Q1 and Q2 and we're checking if these are equal. So it's going to look, okay, is K1 and K2 equal? Yes, that's true. Is K2 and K1 equal in this case? No, that's false. And then in this case, K1 is not equal to K2. So because we have true, false, false, it is false that all of them are true, so it's just going to return false in general. So just think of it as when you're comparing two ordered dictionaries, this is kind of what it does. And then when you're comparing two regular dictionaries, just think of it as just comparing two sets, because technically when you're looking at the keys, it kind of treats it as two sets. Although when you're just comparing P and Q, it kind of takes the entire thing and not two keys. So let me go back to what I mentioned about the keys being sets. So if I go ahead and do it like this, like I mentioned, these are treated like sets because we can still do the operations that you would normally be able to do in a set. So let me go ahead and delete one of these. So now we have it like that. So if you remember in my previous video that I made before about sets, if we just print Q2, what we have is just simply 1 and 3, as you can see here. But if we take Q2, and this is the union operator, having an equals updates it, and we update it with the values in P2. So that means it takes all the values in P2, which is this one, and it updates this one. So if you do that and print it, what you have is now the Q2 dictionary was updated to match the items that were in P2. So, like I mentioned, when you do it that way, the keys are treated like a set because we can still do set operations on there. And now we'll just go into some of the other examples that we have with an ordered dictionary that are not in a regular dictionary. So we can kind of just delete this one here. We'll just delete that one, and then, I mean, I guess we could just technically just do it like this, just to make it easier. We'll just, again, print out P2 like that. It doesn't match, because I forgot to put that here. So we have 1, 2, and 3 like normal. Good. And now what we can do is there's something called P2 dot move to end, and we can just type in the key we want, 2. And then we'll just print it out again. And as you would expect, the 2 key and value will be moved to the end of the dictionary. So now we have it regularly, and we basically just moved it to the end, and then we have it, at the end. And then the same thing, of course, we can do it with 1 as well. Do it like that. And now, of course, 2 is moved to the end, and now 1 is moved to the end. And then now, look, we have it reversed, which obviously is an inefficient way to reverse a dictionary. What we could do instead is just literally print P2, actually, reversed P2 dot items. We'll go ahead and close this, and we'll do the unpack operator, and this should still reverse it. Right, so the doing move to end twice did reverse it in a bad way, but the order dictionary does also have a reversed. It does work with reverse, so it brought it back to the original one that we had, which is 1, 2, 3. I think that was added in 3.5, because originally, of course, it was always in a regular dictionary, but this was more recently added to the order dictionary. So the next one is oh, here's another thing that's really good with only order dictionaries is if you go to, let's say, pop item, we'll just delete this so that way we have it the same way of 1, 2, 3. If we just print P2 dot pop item, what do we get if we have it with nothing? This is what a regular dictionary would have. It just has pop item and there's no arguments. Pop item automatically takes the last one out. But specifically with an ordered dictionary, we can put in false, and that makes it so it doesn't take it from the back. It actually takes it from the front. So, which kind of does lead into my next lesson, which I think is about a double-ended Q. A double-ended Q, you can take it from the back and the front. So as you can see, when you pop it, it takes it from the front instead of the back, and it actually does remove it. So if I were to do this, and as you can see, it returns the one that was removed, but it also actually removed it. So like I said, this is only available with the order dictionary. If you made this into a regular dictionary by doing it like that, now it's a regular dictionary, it gives you an error because it doesn't take any arguments. So you would have to remove the arguments, and it would still work, but it could only take the last one. You need to have an ordered dictionary if you want to take the first one. So that's it for the things I'm going to cover in this video. Of course, now we'll just move on to the hacker rank challenge. This one is a bit weird because this is actually from 9 years ago. It's pretty old, which I believe was before they made the change that made it so the insert matters, or the insert is remembered for dictionaries. This doesn't really test the ordered dictionary anymore. You can still use a regular dictionary and it still works. But basically the premise is we add all these to the dictionary, and then we have to print out the dictionary in a specific order, and we need to add up all the actual values. So for example, potato chips 30, potato chips again another 30. So we have potato chips 60. So this is pretty straightforward. And like I said, it is kind of weird because you don't necessarily need to use an ordered dictionary. But from collections import ordered dictionary, we'll get a loop int input, and then we'll just do ordered dictionary equals ordered dictionary, and then for underscore in range loop. So we're going to be looping 9 times. We need to get name count equals input. And something that we can do here that's interesting is we need to take this and split it. Normally we would split it by the space, but just I'll show you. If you just use regular split and then well, this isn't going to work because it's going to split it into 3 by default. So if we just do names, and then we'll just print out names, or we'll just print out length of names. It's just going to give us 3 for this because, yeah. So how do we get it? How do we have banana fries as one string when it has a space in it, and we use the space to separate banana fries from 12? Well, we're only going to need 2. We're going to need the key and the value. So we'll have the name, which will be banana fries, the value, which will be, count, because that's, the number here. And instead of using split, we can just literally use right split. We'll just put our delimiter here, and then starting from the right side, which delimiter are we going to split? So we'll just put in 1. So that means that it's going to split it 1 time. If you put in 2, it's going to split it here and split it here, which will give us 3 values. But we're only going to put in 1 because it's only going to split this, and then banana fries will be stored in name, and then the 12 will be stored in count. So if we were to do that, name, count, go ahead and run this, you'll see that it does it properly. As you can see, our output is just exactly what we're expecting. But we don't need to print it, obviously. So now we can just check if name in OD, then simply OD name plus equals. We actually need to turn count into an integer because it's the default to a string. And then else we can do OD name equals int count. Of course, it would be kind of easier to have this as a default dictionary. That way we don't even have to check, because as I mentioned in my last video, the good thing about having a default dictionary is that if it doesn't exist, it automatically puts it in. It automatically puts in the string as an integer, or puts in that value as an integer. But that's just that's just a completely separate thing. So in this case, we can just do it this way. Now that we have the dictionary loaded, we'll just simply print it out. So for item in OD, we can just print item and then OD item. That should give us what we want. And it's going to maintain the exact order, because whether it's a ordered dictionary or a dictionary, it's going to do that anyways. Like I said, if it was, a while ago, you would need to use a specific order dictionary for this, but because they made that change, it kind of makes this problem trivial. But that's it for this video. If you found this video helpful, please like and subscribe for more coding challenges. Let me know in the comments if you have any questions or suggestions for future videos. See you next time on Kuya Code. Paalam.